Hello, ladies and gentlemen. We are here back at the circulatory system, and we have been talking about the heart. And today we are specifically going to go to the blood vessels, their structures, and their functions. Okay, first off, in looking at the overall structures of the blood vessels, you have the artery, which they've colored red. Remember, they're all kind of red, and the vein that they've colored blue. You can see the arrows indicating the direction of flow. So the artery is away from the heart. The veins are towards the heart. Okay? Usually that means that the arteries are oxygenated, but remember there is the difference because you're talking about the pulmonary arteries going to the lungs in order to get oxygen. Okay, if you look at the structure of the blood vessels themselves, if you look at the difference in the thickness of the walls, the arteries have much thicker walls than the veins do, and especially of this elastic material. The protein is actually called elastin because of its stretchiness and its bounciness. This is necessary when you're talking about blood vessels, and especially the arteries. The pressure coming from the heart when the heart beats actually causes a large amount of pressure to enter into the arteries. That causes the blood vessel, the artery, to stretch out in all directions when that push of blood gets shoved into the blood vessel. What actually happens is because of this thick layer of elastin, the arteries can deal with the pressure and they bounce back in, and that continues the push of the blood down the artery. The heart itself really only causes the initial pressure of the blood into the arteries. Now, that stretch where the blood vessel goes out and then back in is actually what we call the pulse. The pulse, when you feel it at your neck or your wrist or something like that, is actually the blood pressure in these arteries as they stretch out and bounce back. Now, you see both the arteries and the veins have connective tissue on the outside. That's that collagen that we've talked about before. The outside, the exterior, is known as the tunica externa. In other words, the outer, external vest or clothing. Okay? That the elastin, that stretchy protein, is part of the tunica media, or the middle clothing. And on the inside of both you have the endothelium, remember, which is just connective tissue that makes up or not connective tissue, it's endothelial tissue, but it makes up basically membranes and things like the skin. So the inside of these blood vessels is very, very smooth. Now, you will notice the difference in diameter of the inside. The outside's about the same, but the inside of the blood vessels is very different. The arteries have a much smaller internal diameter because a lot of their diameter is used up with that elastin. And the reality is most of your blood, about 80 to 85% of your blood, is actually found in your veins, not in your arteries. It's not a split. Okay, now as the arteries are going out to your body, they get smaller and smaller and smaller until you end up at the capillaries. These are actually microscopic blood vessels that are literally so small. Remember that they only let one red blood cell through at a time, and they are only made out of endothelial tissue. So they're thin enough that this is where the exchange happens between the body cells and the blood. So it'll drop off the nutrients and oxygen, pick up the carbon dioxide and wastes. Now, by the time it reaches the capillaries. It has gone a huge distance. We don't usually think of that in our body, but it actually is. Your blood vessels are extremely extensive, and by the time it gets to the capillaries, the pressure from the heart beating is actually so small that it can't push the blood back up to your heart through the veins. So you actually have to have this valve system. Okay? These valves help keep the blood from pumping back down, and also what causes it to move up in the first place, since you don't really have a whole lot of blood pressure, is actually the muscle movement of your legs. And that's why when you sit a lot or you're trying to stay still, you end up fidgeting your body, and especially your legs, is because God had it built into your brain that if you are still, you need to get that blood going back to your heart, and you pump your muscles, which causes the blood to flow upwards towards your heart. The only veins that are going downwards are the ones from your head. Okay? Now, this is a short video. You can see this is the structure of the veins on the right. As you pump your muscles, the blood gets shoved upwards, and then the flow in between causes the blood to come back down by gravity, and it kind of catches the valves found in the veins and causes the valve to shut, as you can see in this image here, and causes the blood to not be able to go back down. Okay, and here is your video.
The pumping action of the heart forces the blood through the arteries and into the capillaries. Only a residual pressure remains for the return transport, working against gravity. The venous system uses a complex pumping mechanism to ensure the return flow of venous blood. The force moving the veins is the muscle joint pumping action of the leg muscles. Through the natural movement of the legs, the veins are pressed together and then pulled apart again. Pressure suction effect, so that the blood is kept flowing. The venous valves prevent the blood from being pushed backwards against the direction of flow. The flaps of the valves act as check valves and have a very important controlling function on venous return flow. They open when the muscles press against the veins, pushing the blood towards the heart. They close when the muscles relax, to make sure that the blood only flows towards the heart.
Okay. Now, that is essentially it for the structures. However, we have a special treat where you get to watch a heart dissection. This is a dissection put on by a university. The person that's actually doing the dissection is a scientist, the other guy is the tech guy. I'm guessing he got to help out because he gets to record the whole thing and be in charge of the recording. Okay? It is pretty straightforward. You should recognize the different structures, and if you have questions, make sure you ask. You're safe.
Hello, I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Del Droege, Professor of Biology at Dakota State University.
Today we're going to dissect the sheep heart, Dale?
Yep. We're going to look at an example of a mammal heart, and sheep are a good example of that. You also can order beef hearts, various other kinds of, pig hearts probably under certain circumstances. But I would say beef and sheep are probably the two most common.
Should we go ahead and get started?
Yeah, which one do we want to cut open? That one?
Try that one first, maybe?
All right. So let's, like I say, I think in this case, again, I take a little bit of this aorta off just because it'll be kind of clumsy, and maybe just a little bit of fat off of here so that we can see what we're...
And as far as, like, cutting away, anything really to watch for? As far
up here around these blood vessels, I guess you do want to be a little careful. You don't want to cut too much, through some of these blood vessels that you would puncture into two or more.
We also meant to have gloves and probably plenty of soap around.
Oh yeah, they're greasy. The fat is greasy, and you can kind of see the shine on our gloves.
So maybe check it, as far as cutting a bunch of that, it might actually end up causing more.
Yeah, I don't think you want to. Yeah, I don't think you want to get too carried away here. I'm just cutting a little fatty where we can see these vessels a little bit. You can see there I'm cutting. You can see there I'm kind of cutting into a vessel already. That's one of them.
So where do you start then, as far as the actual cuts?
I say usually we try to follow the flow of blood into the heart, and so we usually traditionally think about, okay, the deoxygenated blood is coming back in the veins. Veins return to the heart, and it's entering the right atrium, which is right here. And you can see it's this one's a little on the back. So it goes from the right atrium to the right ventricle through the pulmonary artery to the lungs back to the left atrium, left ventricle, out the aorta to the body. So we'll follow that course.
Can be a little confusing. So maybe that extra PowerPoint we have
with
the video.
I think it'd be great to review that so that you really kind of the path of circulation of blood through the heart. I think that'll really help you understand what you're looking at. Anyway, so as that comes in then, so the blood comes in through the blood vessels to the right atrium. So usually you go ahead and open that right atrium up. And it's not going to look like very much. The atria are really just little sacs that receive the blood. So, see, maybe, I don't know, let's see if you can maybe, well, it isn't quite all the way through. Don't want to cut too deep, but there, see if you can open it. See, that'll open up. So,
this one's a little stubborn here. I don't know if we should go with a little bigger one. Maybe. That one's like, it's almost like it's up against there.
Yeah,
maybe we'll try this one here just to get the, well, maybe.
That one we've already cut through.
Try that one there once, maybe?
Yeah, okay. So again, the side here, the left side's thicker, right? And so this is the right atrium here. Cut a little bit of that aorta off.
And you run into this. Some might not be as nice as others.
Yeah.
They're kind of squished maybe, and
different times.
That atrium just seemed awful small, didn't it?
Yeah, it did. And so this is the right atrium on this one. Again, we just would cut it open and just spread that out. You can see it's just a hard. Yeah, maybe you can hold that better.
Yep, the hole there you can open.
It's just good things are. It is just a sac, really. So the blood comes in, and you can see, for the probe, the blood will now go down into the right ventricle.
I think once they make that next cut, it'll actually be easier to see that atrium.
So this is. This will be on your left. It's the organism's right, so it'll be on your left as it runs toward you, and you want to cut down the side. And so take the scissors, and you'll be able to feel that there's a cavity behind there. That's the ventricle itself. And just cut.
Can you really hurt a lot here?
Well, it could be a little bit, but as long as you're not too crazed about it. And so now as we pull that apart, you can see now we're into the.
You can probably see the atrium now easier too, probably.
Yeah. Now see, here's the atrium up here. And now this is the ventricle. You see, I did cut down into the middle here a little bit, the interventricle, but so this is the atrium, and the blood goes down into this larger space, the ventricle. They don't look like big round chambers, so you don't want to get, sometimes you want to think what they look like in diagrams. They don't always look like that. They're going to be closed, and the blood would fill that up.
So what prevents the blood from going back then?
Yeah, great question, because see, the blood comes in here to the atrium, and then as the atrium contracts, squeezes like that pushes the blood down here into the right ventricle. And it goes through this flap, which are called the valves. And this is the tricuspid valve because it actually has 3 flaps. You can't see all 3 flaps in this dissection. And you can kind of get an idea here. The blood pushes through that. So the door, pushes through as it goes down. And then these chordae tendineae that are attached to these papillary muscles here, they prevent, they prevent the backflow. So now when the ventricle contracts and squeezes, blood goes back, but those valves are going to push shut and prevent blood from going back into the atrium. So that's a very important, you want to recognize here the right atrium, the right ventricle, and then the tricuspid valve, which are these little flaps connected by these chordae tendineae, these strings-like structures that keep the valve from going too far back and stop the opening, stop up the atrium so blood flows out of the right ventricle up through to the lungs, through the pulmonary artery, which would be over on, be a little harder to find, but over on this side.
Usually probably, the best way is probably a probe.
Yeah, probe into that. It's going to be a little...
Up behind the cuspid and just...
Yeah, and just push your way.
They're very slippery.
Yeah, push your way in there. I don't think we'll cut into there because it'll ruin our left side.
Maybe cut the left side and show that one later, maybe?
Yeah, we could maybe find that. So it'll be and it's the pulmonary artery that carries away from the blood. Actually, we can kind of go the reverse way, this way. I think
there we go.
Maybe get it.
There it is.
Yeah, you can get it down, and there we go.
If I can hold it there for you here.
Yeah,
so this would be, I'll open this up and you can...
Yeah. So you can see there's where the blood comes down through that opening, and that when the ventricle contracts, it go up, follow where that probe is. Maybe go all the way over here, Steve, and see then it comes out, and that's the pulmonary artery, which leads out to the lungs. And of course, that blood with no oxygen in it goes out to the lungs. It'll get oxygen and come back now to the left side of the heart.
I'll kind of rock it back and forth there so they can see that. So let's kind of go slow here.
Yeah,
I think
so
person could cut that, but it probably end up ruining a lot of structures, though.
Yeah, and there's a lot of blood vessels up there, so you got to kind of be careful about what you're doing. Probe around a little bit.
Maybe one at the end, maybe a student could cut, if you're all done, because it will mess up the other side there.
Yeah, so I think we can probably take that out.
So that kind of describes the right side going to the lungs. Now what?
Right, yeah, and really it's best to think of the vertebrate heart, and particularly the four-chambered heart of birds and mammals, as two pumps. It's got the right side of the heart is one pump. It brings in the blood and then pumps it to the lungs, and then the blood comes back from the lungs, and the left side of the heart pumps blood out to the body. So really, even though the heart is one structure, they are very separated. The right half has one function, the left half has another. Or at least, maybe they both pump, but they pump to different places. So it's a two-part pump.
So all right. Try the left side now?
Yeah. So, here, I'll cut it and can you hold it? So here's the left atrium. Again, the atria don't look like much. You might be kind of a hard thing for you to think about. They just look like this little flap of tissue. They're a little different color, though, sitting up here on the surface.
Almost like broccoli or cauliflower.
Or an ear, like an ear. And so then you just cut that open. And you can see that then that's a little, and it's a sac that can expand.
Pull it open there for you.
Yeah, so it'll expand when the blood is in it, returning from the lung. Okay, and then in the same way, we just go down. I'll go cut down the left side of the, and again, the wall's going to be thicker here. So you might take a couple of cuts as you go through that.
Anything the person can really damage here, really?
Not again. I think you could probably hit some of those, chordaes and things, but I don't think you could do too much damage.
I think you'd be surprised at how much thicker this actually is, too. This is amazing.
Yeah, so let's open it. There you go.
Okay, I'll open this up for you.
Open him up, and I'll point to some things. So there again, the smoother walled tissue up here is the atrium. So that's the left atrium. And then here's this left ventricle, this spacing. Yeah, see how it's got this big, thick muscle here.
I'll just do a quick comparison here. I'll just flip this over.
Yeah, flip it to the right side. You can see. Yeah, so there's the thickness of the wall, barely a quarter of an inch maybe. And here it's more like an inch. Much thicker. Once again, we have a valve. This one's called the bicuspid valve. It just has two flaps. And you can see those flaps here, and again, connected by these cords that prevent them from, you can see it prevents it from going too far back. So when the ventricle contracts, the blood pushes against that, and this prevents backflow into the left atrium.
It's also called a mitral, too. Is it like mitral and bicuspid?
I believe, yeah.
I hear people having that replaced.
Yeah, their valves are one thing that do wear out, and people need to replace them, and they can do that type of surgery, which is amazing.
How about the flow from here now?
Okay. Yeah, now the blood, so the returning oxygen blood to the left atrium and to the left ventricle. When that powerful left ventricle contracts, it goes up through the aorta.
Probably the best way would be the probe
and again, I'd probe, and you can see that probe coming out, hopefully, into this. Yeah. Actually, we need to cut this off again a little here, I think. Shorten that aorta up a little bit, and that probe up, there it goes. Right out through there. So the blood, again, going, yeah, you want to hold that for me? And so the blood coming out of the ventricle, and then because the valve's closed, it can't go up into the atrium, and so it forces it up through this aorta. And so the blood can probably go all the way through, the blood comes up.
Should we cut one of these just to kind of show there's a couple other valves?
Yeah, and that's kind of cool. Yeah, another thing, you got to prevent the blood from coming back. So you, awkward to hold this here so anybody can see what we're doing, but if you cut up into that aorta, awkward to hold this here so anybody can see what we're doing, but if you cut up into that aorta, I don't know if that's going to
throw a
work.
probe in there maybe? Let's see if the...
I think we got it right there. Yeah, just gotta push that back. Oh, here they are. They're over here.
Which one right here? I see it right there. I can hold it back
Yeah.
open for you. There's a couple of them right...
Yeah, there we go. So here's the... So these are these little flaps here that Steve's talking about. These are also valves. These are the semilunar valves because they look kind of like a crescent moon. And so they kind of flap back. And these now prevent blood from, when the ventricle, after the ventricle contracts, it pushes blood this way. Then when the ventricle relaxes, you don't want the blood coming back. And so these act like little pockets. They shut and prevent the blood from backing up into the heart. So they push it out, and then these valves prevent backflow. So they're so-called semilunar valves. They might show it a little bit better in that one we have.
Yeah, this one right here, I think. Let me open this one up here. I kind of open up all this for you here.
Yeah, right here. Well, say that. Here's a semilunar valve here. So this is the aorta, and here's the semilunar valve right there. Both cases I cut a little deep there, but I think it'll be okay. So this would be the left ventricle down here.
Yeah, if I show it right here, I can see it really nice.
Yeah. There's the semilunar valve. So, you know, not a terribly complex structure, but a pretty amazing one. It has, you know, it has these strong pumping ventricles, and it has the valves and things to prevent backflow, and it beats 60 to 100 times a minute, every minute of your life. So it's a, you know, it's an amazing structure, the way it keeps power going, and of course it's absolutely necessary for the circulation of blood through our bodies to bring oxygen and nutrients to our cells.
I would definitely suggest for this one to have the PowerPoints and photos overheading up on the screen.
There's something about a heart, I think, you know, like I say, there's just something about it.
Orientation's tough.
Orientation's difficult, and our conceptions, again, I think we kind of have these preconceptions of what the heart's going to look like. It's going to have these big chambers and all that, and mostly it's big, strong muscle. It's mostly what it is. So I think, yeah, it's certainly worth a little preparation to help you understand what it's going to look like.
Absolutely. Well, thank you so much, Dale.
Well, you're welcome. I think, yeah, it's a great structure, and hopefully everyone will learn a lot by doing it.